Hi, my name is Kevin G, and I'd like to share about our work on aligning unsynchronized part recordings to a full mix. This paper explores the question, can musicians play chamber music together while in quarantine? Our work explores an application enabling a group of musicians to asynchronously collaborate and produce a performance. This diagram shows the system for a piano trio. The system takes 3 unsynchronized part recordings and a full mix recording, and modifies the part recordings to generate a synchronized performance. The system can be broken down into 3 subproblems. In this work, we focus on the joint alignment problem. Note that each part recording is recorded without playing to a click track. Our approach contains 2 repeated steps, aligning a single part to the full mix and subtracting the part from the full mix. The goal is to align the solo parts to the full mix recording. First, we describe the process of aligning a part. A standard approach to aligning 2 music recordings has 3 steps. The first step is to compute chroma features on both recordings. The second step is to compute a pairwise cost matrix based on a cosine distance metric. The third step is to use DTW to estimate the alignment. However, the problem with this approach is that because we're comparing a solo part to a full mix containing multiple parts, this penalizes the full mix for having spectral energy from the other parts. We explore several ways to address this asymmetry, one of which is shown in this slide. First, we compute the CQT on the part and full mix recordings. When computing the pairwise cost matrix, we use a metric that describes what fraction of energy in the part CQT explains the energy observed in the full mix CQT. Note this metric does not penalize the full mix for having more energy than this part CQT. Then we use DTW to estimate the alignment between the part and full mix. Next, we talk about how to subtract out the part from the full mix. This consists of 4 steps. First, we time warp the part CQT to match the full mix CQT using the estimated alignment. After this step, the time warp part CQT has the same dimensions as the full mix CQT. The second step is to break the part recording into segments separated by regions of silence, which correspond to times when the instrument has a rest. Our silence detector is a simple GMM based on windowed energy. The third step is to apply a volume gain to each segment to account for volume differences between the recordings. We consider a range of gain values and select the gain factor that best explains the observed full mix CQT. The final step is to perform spectral subtraction. We subtract each time warped and volume adjusted segment of the part recording from the full mix CQT. After aligning and subtracting the first part from the full mix, we repeat this with the next part recording. At every iteration, we use the most updated full mix CQT with previous parts subtracted out. We collected 12 part recordings and 4 full mix recordings of a single movement from a piano trio. We also constructed a benchmark using the URMP dataset, which contains recordings of 44 different pieces ranging from duos to quintets. Note the URMP dataset is collected under carefully controlled conditions, while the piano trio data is more realistic for intended application. For both datasets, we evaluated the part full mix alignment accuracy. These are the results with the URMP data. We compare standard DTW with chroma features and subtractive alignment approaches with 3 different features. There are 2 things to note about this figure. First, the error rate goes up as we go from duos to trios up to quintets. Second, subtractive alignment with CQTs performs best. Here are the results of the piano trio data. We see that performance depends a lot on the instrument, and different approaches work best for different instruments. In summary, we propose an iterative subtractive alignment algorithm for aligning individual unsynchronized parts with a full mix recording. Our algorithm works well on the URMP dataset, but has mixed results with the more realistic piano trio data.